Thank you, Mr. Toastmaster today. Today, I'm going to discuss with you one of the mysteries of the universe. And I'm going to do it by illustrating an experiment, a simple and classic experiment known as the two-slit experiment. First, we're going to need a source of energy. This box shall represent our source of energy, which in our first case is going to be bullets and a simple machine gun. We're going to shoot these bullets at a wall of armor with a hole in it. Behind that wall of armor, we're going to set another wall of armor with two holes in it. And we're going to put a target behind that. Now there's more distance between those two. They're pretty far apart. Now we're going to take our machine gun. It's going to be shooting bullets. We're going to assume the bullets don't break, they don't bounce off the wall, they just stick into it. Right? So let's go ahead and shoot it off. All right. So now we've got our bullets flying out. Some of them, most of them are going to impact around here. Some are going to go straight through and impact into the wall back here. But a few, more than a few, are going to bounce off the edges of our armored wall. And they're going to deflect somewhere into our next wall. Some of those bullets are going to hit these holes. Remember, they're far apart. So the ones that are coming, they're going to come here. Some of them will pass straight through and just hit the wall back here. Some of them will deflect off the edges. And if we count the number of bullets that we have after we've shot our machine gun a lot, then say if we just did it with one hole first, we get something that looks like that as far as our distribution of bullets. Now we cover up the other hole and we get something like that. Now, if we open both holes, what would we expect? Something like that, a sum of the two curves, right? Here's the number we get from shooting the first one and the second one, and it turns out, you can't see that, but it says N1 plus N2. So, that's perfectly reasonable. Bullets are nice, they come in lumps of mass, they travel in predictable paths, and they pleasantly impact the target. Unless, of course, you are the target. Let's try something different. Let's take this whole thing and turn it on its side. Now, literally, actually. We're going to take the experiment, we're going to turn it on its side, and we're going to lower it in a tank of water and put it so that it just breaks the surface. And instead of bullets, I'm going to put my finger here, and I'm going to go like this really fast. And it's going to make waves, all right? And our waves are going to propagate out. All right? When it hits this, it's going to make a new source of waves in that hole. Now, if we just do that with one hole, what we're going to end up with is the same thing as this. If we measure the intensity. We'll say we'll put a cork here, and it'll bounce up and down, and that's measuring the intensity of our waves, all right? It'd be the same thing here, and if we covered this hole and shot it out here, it's going to be the same thing here. However, if we open both holes, we're not going to get this. Because our waves are going to come out of both of these holes. Now, waves do something that bullets don't. Interfere with one another. So, where the maxima of the waves meet, the peaks, they're going to combine and make a bigger wave. And where the valley meets the peak, it's going to cancel out, and there's going to be no wave at all. And what we'll end up getting is something that looks a little bit like that, called an interference pattern. If you shine a flashlight through a hole, well, I'm getting ahead of myself. All right, so there we go. We have our lights, and this obviously is not the sum of the two individual holes. Let's try some different kinds of energy. Now that we have a great test for seeing if something is a nice lump, which we might call a particle, or something that's a wave. Let's shine a light through here, like I said before. Now, as the light comes through, it's going to act much like the wave, because light, of course, we know, travels in electromagnetic waves. Now, some of you might have heard it's also particles, but we'll ignore that for now. The waves are going to come through, they're going to hit, and sure enough, you're going to get a nice diffraction pattern. There is going to be more light in between these two holes than in front of either hole. I guarantee it. Try it out yourself. It's exciting. All right, let's try something else. Let's try electrons. I mean, what is an electron, really? It's a particle. It has mass. It's like a bullet. It's like a tiny little bullet. All right, so we're going to put a voltage here. We're going to put like a big battery and like that. And so then we're going to throw some electrons in here. We're going to shoot it at it. It's going to be a lot smaller, of course, the whole apparatus. And the electrons are going to do the same thing. And they're going to bounce through here and they come through here. If we shut one hole, we get this. If we shut this hole, we get this. It's going just like the bullets, just like we thought. We open both holes. Holy, we get this. How does that work? They're electrons. They are units of mass. We know them. We love them. We're made of them. They should be this one. All right, well that doesn't make any sense, so we're going to get down to the roots of this and we're going to figure it out. We're going to put a light right here, right in this spot. Big, shiny, bright light. And as the electrons come through, we'll be able to see them coming through these holes. One of these holes or the other, and we'll count which holes they're going through. All right, turn our light on, shoot our electrons, and they're coming through. Okay, we see one hole, one electron. Oh, there comes another electron. Here's one, and here's one, and here. Oh no! Now we're getting this one. We turn the light on, and we don't get this one anymore. We get this one. Those tricky electrons. How do they know we're watching them? Well, now we run back into that problem with light, and then it's kind of particles, right? So it's photons, and every time one of those photons hits one of our electrons, it messes our electron up. And so our electron does this instead of that. It doesn't interfere with itself anymore. All right, well, we'll turn our light down. Unfortunately, you turn the light down just means less photons. So the photons that the electrons that do get hit by a photon, we count it, and it goes on to make this pattern. The electrons that get through without being hit by a photon go through and make this pattern. So we get some combination. Well, geez, that doesn't make any sense. I mean, how can the electron be going through both of these holes at the same time? That's the mystery of matter. And a subject for another speech.